Hello, everyone. Thanks for joining in on this new IEN Talk. First of all, sorry, I don't have much of a voice today, but I'm gonna do my best. So, you guys know that we have been doing this for a while now, and we try to have guys from the IoT Foundation to cover the technological development and also the business development. But now we are trying to create some bridges with companies working with IoT devices. So we will probably have guys from ST Microelectronics, Fireware, Livelium, and our first speaker today is going to be Reiner Schmohl. Reiner is an amazing guy. He's a good friend. We had the opportunity to work side by side with Reiner and his team last year. And he's going to be introducing the amazing XDK 110. Most of you already know this device probably from the XDK to MAM project. So I'm going to bring Reiner in. Hey, Reiner.
Hello everybody. A warm welcome from the Bosch side. I'm the product manager of XDK. And today we want to talk about the ecosystem of XDK. And there is Daniel De Michele, who is, I say, one plate of our Swiss Army knife. So today we will talk about that. And from now on, I just wanted to show you these slides and afterwards go into a question and answer with you. Okay. So as I said, the cross-domain development kit, here you can already see one extension board. That's our ecosystem. That's a hardware extension of LoRa. So in that case, we are also the responsible entity for this extension for LoRa, but there are also others which have the product ownership by other companies. Okay. That's the marketing picture we draw. That is the Swiss Army knife of IoT. On the left-hand side, we have there all our sensors which come out of our wafer fab in Reutlingen in Germany. So we produce them by ourselves, and you will find a lot of them in your smartphones because we deliver them, I think, in billions already to the smartphone manufacturers. And what is in? We have a 3-axis accelerometer in, a gyroscope. There is a magnetometer in, a temperature sensor, a light sensor, acoustic sensor, the humidity sensor, and a pressure sensor. That stuff is all brought together. We started with XDK as a prototyping platform, but nowadays we are able to use that 24/7. So we could manage to bring all the software layers on product maturity level and are now able to bring it, for example, in the shop floor. But there we will talk later on that. We have Bluetooth Low Energy in and Wi-Fi connectivity, and a rechargeable battery with 2.4 gigahertz at the moment for BLE, and the rechargeable battery is 560 milliampere hours. And there is ecosystem, as I already said, accessories, and of course we are also able to bring certain security features in. That's what we have. That's our benefits. We are very, very flexible because we are able to open also the application platform of XDK that enables, for example, XDK to MAM to bring in their own firmware solution for the IOTA MAM layer. We are able to, you are able to program that stuff by yourself, or you can flash ready-made solutions on it, like the layer of Daniel. We have an app in the app stores to get a first overview of the whole story. And at the moment, we are also working on cloud connectivity solutions where we are able to flash them at our factory and bring them to you in a shop floor starter kit to get the data out of the automation shop floor in our fabs. And as I said, there is an ecosystem. The workbench is like the programming tool to get new firmware on the whole XDK, or to program the XDK with ready-made solutions. There is a community where you can get exchange with other developers, and of course there are extension boards for further sensors or connectivity solutions like LoRa, where Danielle already also have worked on. And all this stuff can, of course, be used to get the output equipment efficiency higher, which is very important in our fabs in Bosch and outside of Bosch. Okay, that's the ecosystem in 4 quarters, let's say that way. Let's say on the left-hand side, we have the sensor side. We can extend with a current measurement extension board. So we are able to measure current in wires. The 4 digital input board is to get the andons in the shop floors, that are these nice traffic lights, in the automation stations. We got them to the backend directly without any hassles or harm the automation of the automation line. We can just go to that andon, get the 24 volts signal out, and bring it to the XDK and transmit it from there to the backend. And we are also working with a Switzerland company which is called Logic, and they have a authentication extension board that's at the moment in development. So they are able to use our ID cards within Bosch, for example, or every smartphone, and do authentication. This is very important for our shop floors, for example. In former times, you worked around with a key, and today you can authenticate yourself with your ID card of Bosch, or even with your smartphone. Then the PT100, PT1000 extension is important to go into boilers or on pipes for external temperature sensors, because we learned already we have a temperature sensor in the XDK, but this one is just able to measure the air temperature. And if you want to go into liquids, for example, you need that extension. And then we are working together with Bluetooth Low Energy beacons. We have their GCC30 beacons from Bosch. They are for rough environment, and with that stuff we can go into indoor localization, for example. The connectivity extensions is LoRa. We have one with narrowband IoT, CADM1, and also a GPS receiver. The 5G extension board is on the roadmap so far, and there is also a Sigfox extension board already in the market. The cloud solutions, we have 2 Bosch solutions, which is the XPM 120 production performance manager. Also, it's an open source protocol called Eclipse Unite. And we have the Bosch XDK cloud connectivity for the Bosch IoT suite. There we are able to communicate with MQTT. AWS for the Amazon Web Services cloud. We also communicate to them with MQTT, and also to MS Azure IoT Central Plug and Play. There we are working at the moment with the guys together of Microsoft to get a direct connectivity to their backend solution. And then the firmware solutions, the XDL 120, that is a data logger which brings out our sensor data in high speed, either to the micro SD card or via Wi-Fi to a server in the Wi-Fi environment. And then we have around 20 Workbench software examples which are ready to use. Most of them are open source and in source code. That is your starting point for your own implementation. Like Danielle also used that to go ahead with the implementation of IOTA MAM, which you can see in the last line. And of course, we also can say that there is an open source implementation on Ethereum as well on the XDK. The XDK you can get, that's the bubble in the middle. You can get in a single package, that's the XDK 110, or for the shop floor or something like that. If you need more than just one piece, there is the XDK node, and that is a package of 10 pieces. That's the shop floor starter kit I already mentioned. That is something what we use now in our plans as well to get the data in retrofit out of the shop floor. And we do not want to harm the mission critical automation. So that's why we bring that in retrofit to the automation line and get the data without any influence of the automation and the OEE. That is what is in. That's the scope of the delivery. 10 XDKs, use 10 USB chargers, 10 micro SD cards, 10 of these Bluetooth low energy beacons, 3 of that current measurement extensions. There are split cores. You can just bring them around of a wire which the current flows in, and then you can see the result, how many current is flowing in that wire, non-invasive. And on the left-hand side, that's the PT100, PT1000 board. There we are able to get the certification done at the 31st of August. We have 5 digital input boards and also the link card for the quick start guide and the backend solutions. And of course, instruction for safe use, which is very important because we are Bosch. Okay, that is what is in. That's the first use case. That's the simplest one, because if you just have the XDK in a single box without anything else, you're able to get these 8 sensor data out of the XDK, transmit it with Wi-Fi to the backend or to your smartphone to see the data in the app, or to get that visualized in the backend. That's very easy, and that's already a massive tool for condition monitoring, predictive maintenance, and at the end, artificial intelligence on the edge. That is our second use case. That's the indoor localization. XDK is then acting as an anchor, and the beacons, they are sending out their advertising, and we get the RSSI values of the Bluetooth signal, transmit that to the backend, and in the backend, people can now then see in which area their assets are. And this is very important for also for the shop floor to see where all the stuff, material, and the assets are, to reduce search time. That is most probably the biggest thing also, and lifting up the output equipment efficiency in the shop floor. That is the picture of the shop floor. You can see that traffic lights on top of each automation station, that are the endons, we call them. And with that 4 digital input extension, we are able to get the 24-volt signal of any old automation station out of that endon light, which is a standard, and we bring that to the backend, and or directly to the smartphone in a text message of the multi-line worker. So they have directly transparent the signal on their smartphone, and even if they cannot see the traffic light, they see what's cooking and can go to their automation line and fix the problem and bring up the output equipment efficiency, as I already said. That is the current measurement use case. You can see the split core is open now. You just bring the wire in the split core and close the split core again. And then you will see to each dedicated automation step what the current consumption of your machine or of your accessory is, and compare that with normal values. And if you detect current consumption anomalies, there is something wrong. Even they are too high, then something like a bearing is worn out or something like that, or they are too low, then maybe there is something wrong with your equipment. It might be that that a heater or something is gone, and that's what you can see. So this is good for predictive maintenance and also for quality reasons. That is just an additional signal what you need and what you can see in your shop floor to be sure that your quality is still good and everything works fine. That is the PT100 or 1000 extension board. We have also 2 digital inputs on board and also 2 digital outputs. So if you would like to, that's a complete controller for temperature controller for a single room temperature controller, for example. And there with this external temperature sensor, you got that in all different kinds of sensors. And with that sensors, you can go into the process temperature of liquids, for example, or into air ducts, something like that. Okay, that's all what I have at the moment. So now I think we can go to the question and answer session already. So if Danielle could bring me back to screen and remove that slides, yes, then we can also talk about the solution, what you have implemented already, for example, if there are questions, I don't know.
Yeah, we have some questions. Not a lot of questions yet, but I'm sure we will get some more. So the first one is, of course, about IOTA and Bosch. But let's do this. If you take a look at the screen, you will be able to see the question. The question is from Ale Busser, and he's asking whether you guys at Bosch have plans to offer IOTA-related services like running full nodes or perma nodes. I don't think you will know about this, Reiner, but I don't know if you want to comment on this.
Yeah, I just wanted to tell you that we, within the Bosch company, we do Internet of Things devices based on sensor devices, and what the plans of Bosch Globals are, that is something what I really not can tell much to that. Of course, they are also working with different solutions. As you could see already, there is Ethereum, for example, as well. But I don't know what their plans are there in detail. So I don't know. I cannot tell much to that.
Yeah, I know. Probably, I mean, I think that every company using the IOTA protocol is going to have their own full nodes and perma nodes, because that is going to be a requirement. But of course, we don't know whether Bosch is doing that or not. And if you guys are working on it, not you, because I know that you, Reiner, you work on the specific Bosch connectivity department, and you don't have access to this. But probably that's not going to be public. So let's jump just to the next question. This one is related to the XDK 110 and says, can we use XDK for truck IoT applications?
Yes, of course. I mean, I don't know what truck IoT applications are. The story is that XDK has an IP grade of IP30. So there is no water protection at the moment. If you want to go into an environment where you need water protection, you have to use an additional housing where you can bring the XDK in. But yes, we did that a couple of times to get the XDK in an additional environment. And there you can use it, for example, as a gateway to track your goods, which are on the truck, for example. That is something what we already did. To have an application on the XDK, like a gateway application, and then you can see what is cooking on the Bluetooth Low Energy side, to tracking goods, for example, and to transmit that data. And then you can use either narrowband IoT or LoRa or whatever, or Wi-Fi, to get that out of the truck to the backend, to the cloud.
Great. Yeah. So probably, yeah, you can use it, but you should deal with the fact that the XDK 110 is not a device for exterior use. So if it rains or whatever, you need to have some extra box, a case to protect the sensors node.
Yes.
Okay, this one is really interesting. What is the XDK 110 lifespan if you have it running 24/7 connected to external alimentation? Can you have it running for years? This is a good question, in my opinion.
That's no problem, of course. We have a lithium, a rechargeable lithium battery in, and there is always the story with the charging cycles of that lithium-ion battery. But otherwise, there is no limitation so far. The first XDKs, they have been delivered in 2016, and so far we have had breakdowns on the mechanical side, of course. That's always an issue. But otherwise, from the sensor side or from the board, so far there is nothing which really breaks down. The weakest point, I would say, is the battery lifetime. But if you power that up, then everything is okay, I would say.
Okay, so if you cable the thing with a USB cable, yes, and you have cable, you can have it running for years, and that's not going to be an issue. Okay, so let's move on to another question. So here we have one from Marcus Seidel, and he's asking about the humidity resistance. He says, are there any plans for a humidity sensor extension, for example, for gardening applications? Is the XDK resistant to the humidity and dirt?
Yeah, we have a humidity sensor in, but of course this is just for the humidity within the environmental air. And but we have had already there are different solutions, not as on product maturity level, but we have them had, for example, on the CISS 2019. There was a showcase with external humidity earth sensors. So we hooked them on the extension port of XDK, and then we were able to monitor the earth's moisture, the soil moisture in that application. And so this is working. There are solutions, but they are not on product maturity level at the moment. But if you send me an email, something like that, I can tell you which sort of sensors people have used them. I think it's a brand of a Polish company, I think.
Okay, so let me check, because we are getting some questions here. So let's go with this one from Marcus Frankl. Can I use the XDK in X area? And do I need for every use case in single XDK, or can I connect more sensors to one XDK?
Okay, so the first thing, there is no ATEX certification of XDK because it's IP 330. So there is no way to use it in an ATEX environment. That's the first thing. And of course, we have 8 sensors built in, and there is also a possibility to hook additional sensors on. And for example, these sensor extensions for current sensing, or as I already said, these soil moisture sensor, that would also be a possibility for a extension which can be done in a do-it-yourself way. So there are different possibilities and a lot of also information on our community, which is found on xdk.io community. And there you have a lot of nice solutions where you can see what is possible with XDK. And of course, if there are commercial solutions wanted, we are able to calculate extensions around 500 pieces already, if you're interested in that. And but with XDK, you always have the possibility to do it by yourself or to come to us and to talk about that. This is for extensions, as I said, at around 500. And if you want to go into dedicated sensor solutions, then you can come back to us at around 5,000, something like that.
That's cool. Okay, so here we have a question regarding security and tampered data. Tyson H is asking, what security features are employed by the XDK to ensure data isn't tampered with?
Yes, so at the moment there is no hardware crypto in the silicon already. We use the standard security layers we have on the software side. That is what we have at the moment. And there would be a possibility to do that with an extension, for example, with Logic. Then there is a possibility to have your own code in a secured hardware environment. So with that extension, you're able to have your code in a secured hardware environment. That is possible. But the XDK itself has no hardware entity inside of the silicon.
Okay. Okay, so we are getting a lot of questions, so let's quickly go to the next one. This one is done by Ben Royce, and he's asking, what do you think the hurdles are to mass producing a price-efficient, focused functionality XDK device if such a use case pop up that require hundreds or thousands of each sensor needs?
Yeah, the hurdles to mass production, I have a slide for that, but I have them not in this presentation, but don't worry about that. The story is that with XDK, you can start at once and go with XDK with one piece on the desk of the developer already into, let's say, into the field. That's the big advantage with XDK, because the hardware is certified in much countries all over the world. So you are able to deploy your software codes directly on the XDK to the field in a certified hardware environment. That's the advantage. As I said, with 500, you can come back to us to get to an extension, and with 5,000 we can go, as you said, to that mass production, price efficient, and take out much of these 8 sensors, for example, to get the price reduced. But with XDK, you have the complete customer journey, beginning with one piece on the desk of the developer to maybe 500 to a dedicated solution, and then to go into mass production with a dedicated development reduced to only what you really need in your use case. And that's the story of XDK. That is very, very nice that you raised up this question, because at the moment we do something like that with an ultrasonic microphone in our shop floors to see whether there are leakages in the compressed air system. that is very, very important for Bosch because this is has a very big impact to the carbon dioxide result of Bosch Global, and you have to reduce that, and therefore you have a possibility to have the sensor 24/7 out at your valve islands to see whether there is something wrong or not. And that is a typical use case for testing something on the desk of the developer with an extension board, with the breadboard, which is delivered in the XDK 110 package. Go to 500. There we already have a nice housing for the ultrasonic microphone, and then to go to the dedicated mass deployed sensor. That's the step where we are at the moment.
Great. Okay, so I just want to show this because I love this device. So yeah, I have my XDK 110 here, and well, you guys know what this little fellow can do, but it doesn't have LoRa connectivity. I mean, it is not there, but I can fix that by doing this. And that is amazing. That is what I love, this little guy. So before I think we can do one or two more questions, but we have a lot of questions related to IOTA integration and all that. And as we were talking before this IEN talk started, this is more on the ecosystem end and not on the work that you guys are doing. You guys are doing hardware, and you probably expect from the ecosystem to have these sort of integrations. So to all of those guys asking about the XDK and IOTA, well, we at XDK to Mom, we are one of those manifestations. I mean, the work being done with the XDK beyond what the hardware can deliver is usually on the ecosystem hands. So I know that you guys had some things done with Ethereum in the past, but not Bosch. This is always coming from the ecosystem, and well, obviously we have done things with IOTA. I think it makes much sense to use IOTA because you don't have to deal with fees and you have to deal with gas when you use Ethereum. Well, but that is okay. That is on the ecosystem side. So we are not going to go through the IOTA XDK 110 questions because that is actually more on the XDK to MAM side and on the XDK 110 ecosystem side. So yeah, I think that most of the guys asking these questions already know the answer. I don't know, Reiner, if you wanna add something.
Yeah, I can tell you that we of course are proud to have that open source implementation of XDK to MAM. This is a good thing because each piece of open source software, of course, also makes our ecosystem bigger, and that makes the XDK bring the XDK to a higher value because there you can find someone GitHub code for Ethereum or for IOTA, the MAM implementation, and that is something which is nice to have, and it shows how flexible XDK can be used in all different things. And that's what we have at the moment. And we are very proud to have such an open system to be able to even remove what we have implemented and use the bare metal to get high speed out of the analog digital converter, something like that, and to use XDK to really go into the shop floor and do body sound sensor, something like that. That has also been done, and there are also implementation in China, for example, for their Ali operating system. So XDK is used very, very flexible. I also have used it one time on a boat of Lake Constance to bring the heading of the boat to the sun because you want to have the beer in the shade. and not in the sun. And then you can automate with the magnetometer the nozzle of the in front, and to bring it always in the right angle to the sun. That's something what you could do, or other guys have also done automations in liquid factories, or even measurements on a workpiece carrier. There is also a nice video in the web. So there are a lot of use cases around XDK because it is that flexible, and people can bring their own application on the software side. That's very important, and that also gives Daniel the possibility to do his XDK to MAM implementation on top of XDK. And that is really great, I think.
Yeah, that is amazing. Yeah, the fact that these sensors node is so powerful and can deliver all the features that delivers. I'm sure that's gonna be a key to have more integrations in the future. And I gotta say that XDK to MAM is now integrated with Streams, which is the improved MAM version. So shortly we will have some news on that. So let's take one more. This one is about the XDK and the CISS. This is something we were talking about before the live stream started. So I don't know if you want to comment on this. This guy is asking, would you recommend the XDK or the CISS for industrial application? I think both can go, but if you want to comment on this.
Yeah, I mean, we have to go into the differences of the CISS and the XDK sensor. And from the sensor perspective, there are not much differences. So where's the difference? The CISS sensor has a much higher IP grade. It's IP54. Naturally, like native, let's say that way. So you don't need that additional housing to protect XDK. So that is one plus point for the CISS sensor. But on the other side, the CISS sensor is a data streamer. There is no Wi-Fi. You stream the data out via USB. And you know the USB cable has a length of 5 meters maximum. And then you have to have a gateway. And that's the difference to XDK, because with XDK, and for example, the shop floor starter kit I showed you before, you're able to go into the shop floor, just bringing some power for the XDK in and transmit that data out without any gateway to the backend via the existing Wi-Fi infrastructure. And there is also one important difference. On the CISS sensor, you just have that raw data streamer, let's say it that way. And with XDK, you can implement or use that already ready-made solutions we have ready for, as I said, AWS Cloud, for Azure Cloud, for the Bosch IoT Cloud, or for the PPM, which is the Production Performance Manager, Nexeed IAS also called. And that is the difference. So you have much more of these firmware implementations ready-made, or you're also able to put your own stuff on. And the CISS sensor is a closed system, and it's a data streamer to USB, and there are the differences. If that is okay from you, that the data streamer capture your needs, then everything is okay. The IP grade is higher than XDK, of course.
Okay, so I would say that the most, as you said, the two most important difference are that A, you don't have Wi-Fi, and B, you're not able to play with the code and to have applications to interact with the device as you have with the XDK 110. That is what I understand. I didn't have the chance to play with the CISS yet, but I understand that it is a much more closed application that you have to deal with.
Yes.
Okay, so I think we Let's do one more, and then we are good to go. This is we are 39 minutes in, so this is very good timing. This one is from Sharon Parnekar, and he's asking if the XDK is certified for functionality safety, and if yes, which level, and if not, is there a plan for this?
No, we don't have a functional safety certification for XDK, and that's also not the plan to go into that. The story is we do IoT, and in IoT, you would like to get additional data out of your processes, or in this or manufacturing, for example. And the automation in the machine itself, that stays for functional safety, and we bring in additional data which are often also not even calibrated, and you don't even need that, because what we detect is what is abnormal and what is normal. And with that additional data, you can combine these data, for example, within the XDK already, to reduce the transmission of the data to the backend, which is very, very important. I can tell you that in our shop floors, we see that to get the generation of the event to the XDK itself is a key feature in the XDK. In former times, we say sense, think, connect, act. And we see that this is also important for all these future things which come up, which is artificial intelligence. And therefore, of course, you have to get the data in the first step to the backend to have a deep big data project. But at the end, you have to get the artificial intelligence to the edge side, to the sensor itself, to be able to reduce the huge amount of data. The story is, at the moment, we have one sensor at BCDS, which produces a raw data stream of 1.5 megabyte per second. It's just one sensor. And nobody wants to get that information and to analyze that data. In the first step, yes, because the algorithm to reduce the data is not ready, it's not done. But at the end, these reduction of the data transmission you're able to do that if you bring the artificial intelligence to the sensor itself, to have the neuronal nets there, and to get the then compressed data to the backend itself, to reduce the data transmission. And often you are not able to bring the data to a backend. For example, if you are on a vehicle and you want to get to analyze your vibration of your motor, for example, your engines, then you have to get the generation of the event directly on the sensor itself, and you just are able to highlight a lamp on the dashboard of the driver to get them the information that he have to move now to a service point. Otherwise, the whole machine will break down in a couple of days. And that is very, very important to also be able to get the efficiency of the equipment high. And that is something which we are able to bring to market, because with the XDK, you have an open system, you're able to deploy your algorithms, and at the end, also artificial intelligence or neuronal nets, what already people have done on base of XDK1. So there is a company called Notion, like know-how and motion in one word. And that company is able to deploy a neuronal net on the XDK itself. So that is great. And this is an example why this is so important to have an open system there on the sensor side. And that is what XDK is.
Amazing. Okay, I would like to do one more question because I really want to know how you will answer this one, Rainer. But I promise you this
Okay.
is going to be the last one. This is from Ben, and he's asking about any exotic use cases that you thought or encountered. Probably you want to tell us something about this. Can you read the question, or do you want me
Yeah,
to
yeah,
read?
yeah. No,
Okay.
no. Any exotic use cases you have thought of your encounter that most people would not have realized or considered? So he want to go for the next pitch night somewhere and want to have the good idea from me. Um, well, I can tell you that there are the MEMS sensors. They will be everywhere in future, and I can tell you why. Because they got more and more cheap, and there, for example, if you see that glass, if you would have there like a sensor in the bottom of the glass, and you could get the energy out of the differential temperature of the outside, which is at the moment 30 degrees Celsius in Germany, and inside, most probably there's ice in. Then you could go to energy harvesting system and to use there a magnetometer, a accelerometer or gyroscope. And if you are in the bar and you lift the glass up and it's empty, then you can send that information to the bartender to get him the hint that the glass is empty. And then he knows in this corner over there, there is a good opportunity to sell one more beer. And that might be a very interesting use case for each bar.
It sounds like a bit over engineered, but yeah, that is actually a
Well,
very good idea.
you will see
Okay.
that system in short time, I think.
Yeah, Ben is gonna do it. Okay, okay, guys. I think that's it. We have 120 viewers on our peak, so that shows how much interest there is from the IOTA community, and probably also from the Bosch connectivity side, because they already shared this on their Twitter. So I want to thank you a lot, Rainer, for dedicating time to this. I think this is very important for the IOTA community, and for you guys to share what this amazing Swiss Army knife can do. And I want to also share thanks, of course, to everyone who tune in for being here as usual. So that's it. If you want to add something, Rainer, go ahead, and if not, we can wrap it up.
Yes, of course, I would thank to Danielle to have the implementation of XDK to MAM, which I already said. We do appreciate that. And each open source contribution will help us, the system, the ecosystem. And thanks a lot for the invitation. And see you next time, all you guys on the IOTA side. And have a nice evening. Thank you.
Okay, bye guys. Take care. See you on the in the next IEN talk.